Hi students, welcome back to the introductory video lectures on medical imaging. In this video lecture, let's try to answer few more questions that are commonly posed by students. What are the medical imaging software tools that I can start with when I start studying about this medical imaging course? In this again there are different types of questions. For example, my goal is to just visualize the results that I have got as a part of my program, and I want to analyze those results here are the images. So what are the kinds of tools that I could use for this purpose? Another scenario is that there are a set of existing algorithms and you want to build a pipeline of your own with those algorithms, and you would like to have a control over the parameters of the algorithms, and in addition of course you want to take a look into the resulting images that you are obtaining. The third category is, for example, it's not just using the existing algorithms, you want to build your own algorithms and integrate with the existing algorithms of course and analyze the results. In this video lecture, we'll take a look into some of the commonly and widely used software tools for achieving this. There are many. I would give a more detailed list a little later, but I'm just making a vague distinction here. One type of tools being GUI based tools, where you could visualize data and also where you could select certain algorithms and have a control over those parameters. So what I list here from which you could begin with is ITK-SNAP, 3D Slicer, Mavis Lab. Again, you would see few more tools at the end of this presentation. What I will do here in this presentation is I would give you a brief demo of ITK-SNAP and 3D Slicer. Another category that I would make is programming tools that need not necessarily have a GUI based control for building your algorithm, and one of the popular one is the Insight Registration and Segmentation Toolkit, which is commonly referred to as ITK. I would also give a brief introduction to ITK, and if I have to mention just a couple of other tools, I would say MATLAB's statistical parametric mapping tool referred to as SPM tool and FreeSurfer tool. This is what I would briefly touch upon in this presentation. As I mentioned, I would give you a demo of ITK-SNAP and 3D Slicer, and I would give a brief description of ITK, SPM and FreeSurfer. And finally, I would give you a list of other tools. Let's start with a brief demo for ITK-SNAP. So this is how typically that looks like. Let me open some image. The images that I am going to show you here are also you could download from the page available in ITK-SNAP itself. Basically these are images are part of a brain tumor challenge that has been hosted online with the data being publicly available. So I am going to open some of those images. So for example, one kind of format is MHA. These are all MR based images, right? Let me open one image. For example, this is how the image would look like. This is the axial slices, okay, orientation in the axial direction, and this being you are looking at it in this direction, so that being sagittal and this being coronal. So you would be able to, within the ITK-SNAP, you could look at in terms of axial direction, you could look at the slices in the sagittal direction, and of course in the coronal direction. This is a FLAIR image. For now you treat it as one of the types of MR images. There are different types of MR images. So FLAIR is one of them. So there is a tumor here in this region. So you could in fact see an intensity difference here. I will only touch upon few things here. You explore it in more detail. For example, certain things that you need to look upon as image information. This image is 160 by 216 by 176 pixels in the direction of X, Y and Z. The spacing is 1 mm in X direction between 2 pixels, 1 mm in Y direction and 1 mm in the Z direction. Your origin information is here. You could also play with the contrast here to look the image in a better way. This is something referred to as image transforms. We will come to it a little later to get a more detailed view of that. You could introduce more control points here, and you could get a better way of contrast. So for the time being, I would reset it to whatever it is there. Right now we are looking at a grayscale image. That need not necessarily be the only way you look at it. For certain purposes, you may prefer going to a different mode. You could in fact load other types of images, for example DICOM, where you could see a lot of tags, each tag containing some unique information, right? So this is what you could see under image information. I would just point out few more things here. I'm loading another image as segmentation, right? I could those are the masks of two labels. One is edema and another is referred to as active tumor. You could overlay them on this image, and then you could in fact control its opacity. And if you want to make an editing of these labels also, this label editor, you have it, so you could do that as well in this tool. The output of segmentation results from your algorithm, you could overlay them here on the original image, and you could look at them. You could in fact generate the 3D volumes as well of this. You could do a lot more stuff here, which I would leave it to you for exploration. And also you could take a look at the statistics of these volumes as well. And further, within MR there are different kinds of modalities which are referred to as T1 contrasted image, T2 image, flare image. You could in fact load all those things here at one stretch and see them simultaneously. To do that, let me first unload all the images. There is another format where what all you want to see, you could keep them simultaneously here. You could visualize all of them in one go, because sometimes each of them would give you complementary information. I could in fact, if I want, I could load the ground truth as well on all those images, load as segmentation, right? And I could play with the opacity of this overall label opacity and see, and you would realize once you play with it that for example active tumor might be visible in one, let's say flare better, and edema might be visible in some other modality much better. Okay, and you could in fact then generate the volumes of these structures and do lot more things. You could export them and do many things, right? So as I mentioned, this is the tool that you could use for visualization of your images, visualization of your segmentations, either ground truth segmentations or segmentations that you have obtained as an outcome of your algorithms. You could overlay them on one on the other. You could get their statistics. If you want to create your own ground truth here, this has tools for performing the segmentation. So for example, I'd go here and do that, and it also has some basic methods for performing the segmentation. Let us say something we would later discuss is active contour based methods. So it gives you a GUI based interface, and also it gives you a control for playing with the parameters, and it also allows you to give some seed points that serve as the starting point for the evolution of your segmentation results. So this is what ITK-SNAP is about. The objective here is to just to introduce you to this tool, and you are expected to explore in more detail about this tool. And after that, let me go to the demo for 3D slicer. I would call this tool as a monster tool. It has so many features, so many existing algorithms that have been implemented here, so many modules here. Once you get used to it, you could do a lot of things with it. For example, look at how many types of algorithms have been there which you could use from this GUI. To name few, I could actually come back here. Let me show you some widely used one already present here. For example, you could do segmentation algorithms are there, filtering, lot of filtering algorithms, you could call them, build your own pipeline. Surface models are there, endoscopy, there are certain things related to that, certain utilities that you could use here. You could use it for diffusion MR imaging related algorithms, registrations you could perform. You could acquire some informatics on top of the results that you are getting there. In this demo, we will focus more on the visualization aspects of 3D slicer. You have, for example, in the slicers tool itself, there are different kinds of sample data that you could download and experiment with. From the same thing, I have downloaded some data related to the head. I'll use it here for the demo purpose. Let me right away load this data that I have already downloaded. Okay, so this is the data that has been already there. Okay, let me also give you a brief introduction here. So there are different ways of visualizing the data here. You could have a control over this. For example, if I go to the conventional mode, this is how I would visualize the data. Volume on top, this is your axial slices, sagittal slices, and coronal slices. This is the volume. You could see it here in a different ways. For example, this is 4 up. You could choose triple 3D, and let me standard 3D table, conventional. I'm going with one of these layouts here, this being axial, sagittal, and coronal. I could traverse through these slides here, okay, and sagittal by controlling here, and coronal here. I am in the data part. I could play with this data. For example, I could, these volumes are extracted already. I could hide them or do that. For example, this is the skin. If I hide it, these are the volumes that I could see. And skull bones, so this is the skull bone that I am hiding and removing here. And then you could let me hide it for a moment. Then this is the right eyeball. Okay, this is there should be a left eyeball here. This is the left eyeball. And then for example, hemisphere white matter, this is the white matter. And then optic chasm, this is the optic chasm. And then optic nerve, this is the optic nerve on the left hand side, optic nerve on the right hand side, optic tract on the left hand side, and optic tract on the right hand side. So this is how I could play with the visualization part. We'll do a bit more than that now. Let me go to models. We could in fact control the transparency of each of them as well. So let me first go to the skin and make that opacity to, let's say, 0.5, so that I would be able to see simultaneously the objects inside as well. Similarly, the skull bone also, let me reduce its opacity so that inside the skull bone also I could visualize what is there. Hope you are able to see that. Another thing is, I could in fact along with this show you the particular slice here. Now by moving it, I could simultaneously on the volumes as well as the slice is something I could show you with. Let me also take a look at this slice, maybe not this slice. Okay, now I could move here and see the information whatever I want to take a look at, simultaneously the volumes as well as images. Next thing let's do is, let's try to play with the way the visualization is made here. Okay, now assume that I would like to visualize this optic chasm in more detail, and to this end we want to hide the white matter on this portion. So what I did for that is I went to the advanced features and I went to this green mode, because this is where I don't want the things. So green slice clipping, okay, and with the -1, and I am doing this part for white matter hemisphere. And now I can adjust where exactly I want to do this. Just check if I could see. optic chasm here. Right. Let me now go to the volume mode so that it's visible 3D only. Now you could see here. I could in fact move it a bit here. I can come forward. So let me again go here to conventional widescreen. See how it is visible here. I could further come down a bit and again come back here to just the 3D volume. See how nicely I could see that here. That's the optic chasm, and I had a control over what I could see here. There are again few more ways of visualizing it. For example, this is how I could take a detailed look from different views. As I mentioned, it has a lot of features. For example, you could apply various filters, in fact write your own algorithms. So you could see here, you could write them in Python, and there are ways that you could integrate it nicely with this 3D slicer. Let me close this for now. That's about the 3D slicer part. And now if you want to do a very serious programming in medical imaging, one of the best tools and my favorite tool is Insight Segmentation and Registration Toolkit. It's an open source cross-platform library, and this is a widely used one. And two tools that we have seen, ITK-SNAP and 3D Slicer, are built upon this tool. For example, thresholding, there are various filters for doing thresholding based segmentation, edge detection, and then intensity mappings. You want to find out the gradients, then second order derivatives, neighborhood filters, smoothing filters, blurring based filters, edge preserving smoothing you want to do, and a lot of things. Geometric transformations you would like to do. You want to resample your image, you want to analyze the image in the frequency domain, you want to extract the surfaces of it, you would like to perform registration. Registration has again different modules, for example the type of metrics you are going to use, and at what resolution you would like to do, what are the type of transformations you would like to use for performing the registration, type of interpolators, type of optimizers, lot of things. You could pick each module that you would like to want, and then you could write a very nice programming here. This follows the concept which is commonly referred to as extreme programming. That's done in C++. Somebody who would like to get a mastery over programming in medical imaging, this is a strongly recommended tool. And then again, lot of algorithms for segmentation are also there. Let's say region growing algorithms, watershed based segmentations, level set based segmentations, and some hybrid methods as well. And another tool, maybe this is a bit more specific tool, this is referred to as SPM tool, available in MATLAB, statistical parametric mapping. Particularly for functional MR imaging, this is widely used. Let's say you want to build a template that you could use it to compare with the functional MR imaging of another subject and see where you could see a significant difference in the functional response. So this allows you, for example, to make a normalization from multiple images, create a normalized image, you compare with a new image, and then say that the response in so and so regions is statistically significantly different from the normal image, and so on. This is like a toolbox built on top of MATLAB. FreeSurfer, again if you are doing something referred to as parcellation, particularly again for MR imaging, this is widely used. An open source tool. You could do various tasks required for this purpose, like skull stripping, image registration, subcortical segmentations, surface reconstructions, tractography also people use it, functional MRI, this is used it, and you have a visualization GUI as well for doing this. These are not the only tools, there are quite other tools also. Simple ITK, for example, this provides, many people in the beginning find right away using ITK difficult, and also for those who are not very comfortable with C++, but these days many students are comfortable with Python. So it has a nice wrapper simplifying the commands to be used. It has wrapper in Python as well, so that's simple ITK you could explore. If you would like to do your programming in Python so that your integration maybe with other modules becomes easier, then MedPy is also a widely used tool for medical image programming that you could give it a try. MedInria, it has a set of tools, lot of tools are there, small tools are there, where for example you could do a nice way of registration. It can do the fusion of images. You could overlay one image on the other, and even before and after registration with different opacities, and you could see it nicely. So this is a GUI based tool, you might find very handy. ITK is more about performing registrations and segmentations and commonly used image processing tasks. On the other hand, if you want to do visualization aspects of it, this is by the same company Kitware that has developed primarily the ITK. You have VTK also. This is visualization toolkit. You, for example, 3D slicer and ITK-SNAP that you have seen uses both ITK and VTK on the back end. That's also a very good tool if you are going to deal with visualization aspects, creating the meshes and surfaces. This is something you can go for. Again, from the same company Kitware, ParaView. This is again very good for visualizations. I used earlier this tool for visualizing the 3D deformation fields once you are registering one image to the other. FSL, this is another tool that people use quite a lot, particularly those who are into functional MR imaging. ANTS, this again, some of my students used it for generating a group wise template from multiple images. So for generation of average images, which are commonly referred to as templates, a reference image from a set of multiple images, this is something one could explore. Those who have been coming from computer vision background may be already familiar with OpenCV, and this is very rich in terms of very recent algorithms for image processing. And in fact, with some effort, you could use all those things. You could adapt them to 3D, and you could use OpenCV as well for medical image processing. Then there are other tools like ImageJ and Fizzy. Again, computer vision people doing image processing and computer vision will be very familiar with them. With some plugins, you could in fact use them for medical imaging as well. I hope you now got some idea about different tools that are available for kickstarting your programming. Here comes the second assignment for you. You are supposed to use 3D slicer for this purpose. You identify one task that you would like to do with 3D slicer. You explore on your own. Going to 3D slicer, you have lots of data sets there, you have lots of tutorials available, so you go through them and you come up with some problem. For example, your problem could be the way I showed you how to visualize the objects of your interest in an effective way. That's one thing. And then maybe you want to perform segmentation, so how to perform segmentation, that could be another problem. And a different problem could be, you want to register two images by just simply loading the images there, choosing the algorithms and their metrics, performing it. So you give a demo of that using 3D slicer. Or you might want to write your own code in Python, then show how you could integrate this code, you could plug in this code into 3D slicer. So that's the assignment for you. Give it a try, and your video could go up to 15 to 20 minutes depending on the complexity of the problem you are picking up. So show us how you could use 3D slicer for a particular medical imaging related task that you wanted to demonstrate. Thanks for watching, and see you in the next video lecture. Take care. Bye.